Okay, first and foremost, let me tell you about certain things about the structural testing. Okay. Structural testing, it is also called as glass box testing or white box testing. Basically, it focuses on the testing of structure of the code. The testing of the software it is based on the structure of the code. We are going to find out the loopholes with respect to the code structure or the logic that you have written or the way you have written the code. Okay, we are going to focus more on the code rather than the functionalities that you have implemented. Okay, so that's why the name is white box testing, or it is also called as glass box testing. Okay, and we call it as structural testing as also. Okay, so you have to know there is a difference between black box testing and white box testing. Okay, black box, as the name itself indicates, you are basically focusing on the functionalities, how you have implemented the requirements or the functionalities. Okay, you are going to find out the loopholes with respect to functionalities that you have implemented in the software. Whereas white box testing or glass box testing, you are basically focusing on the structure of the code and you are studying it and you are coming up with a certain faults associated with the code. Okay, thereby you are testing the software. That is the basic difference between white box testing and black box testing. Okay, so one thing you have to know over here, that is about the code coverage. What do you mean by code coverage? Okay, it is one of the measures which basically tells you about the degree of which or the extent to which the source code that you have written is being tested. And I'm going to express the code coverage in terms of percentage. Okay, I've already told you about this, but still I'm stressing on this particular uh, terminology, code coverage. What do you mean by code coverage? It is a measure and it is basically associated with a structural testing. Okay, we are going to give certain number in terms of percentage, which tells that how much, to what extent you have tested the source code. Okay, that is what I call it as code coverage. Okay, and you are going to find out certain areas of the program which are not being exercised by the test cases that are being written via this particular structural testing or white box testing. Okay. See, based on the requirements, usually what happens in the industry is that based on the requirements, you have various teams for development of the software. I have told you, one team is meant for requirements gathering, one team is meant for coming up with a design for a particular software, one team is meant for writing the code or programming or development of the software, and one team is meant for testing purely. Okay, they are involved with only testing, no other works for them. Okay, and one team is meant for maintenance of the software. Okay, so as the moment you get the requirements from the client, you are going to write the test cases based on the requirement. Thereby, once the particular module is been designed, you are going to test that module against the requirements given by the client by writing the test cases. We have seen how to write the test cases in the earlier session. Okay, so in some scenario, what happens is that the test cases, even you have written n number of test cases, some part of the code may not be traced by the test cases, or it might have been missed out by a test case, and thereby you might have missed out certain fault associated with the code which is being uncovered by a test case. Such uncovered part of the code can be found by going for structural testing or white box testing. Okay, if I go for white box testing or structural testing, I can enhance the number of test cases, or I can increase the number of test cases in order to have more coverage with respect to testing. Okay, and I can come up with certain quantitative measures with respect to code coverage. Thereby, you have a confidence how much is the coverage with respect to tested software. How much you have tested a particular software. You have a confidence because you have a numerical measure with you. So most of the times they do prefer going for this particular structural testing. Okay. After that, Okay, we have gone through which all are the methods. So far we have studied statement coverage, decision coverage, branch coverage, as well we have covered one more thing, that is condition coverage. Okay, let us just study the numericals based on these things. Okay, let me take up the first one, that is statement coverage. Okay, as the name itself indicates over here, you need not hide the stuff over here. Please focus on the terms. You can write in your own words if you understand the basic concept involved. Statement coverage, it is one of the white box text testing techniques in which you are going to test all the executable statements in the source code at least once. This is most important. The key terms involved in this particular definition are, it is white box testing. See, the moment you write this thing, the evaluator will get to know that you know what exactly you are writing and you have the idea. It lies under the category white box testing technique. And what you are doing, you are basically dealing with the statements, testing the statements, that you execute statements in the source code at least once. This is very, very important. Key terminology involved over here. Okay, and what you're doing, you are basically uh, going through all the executable statements in the code at least once. Okay, and this is basically used for calculation of the number of statements in the source code which have been executed so far. Okay, and it is also used for arriving at the scenarios based on the structure of the code and the test. By looking at the executable statements within the source code, you will arrive at a particular scenario, okay, which is under test. That is what we call it as a test driven development, TDD. You have gone through it, test driven development. You are going to test simultaneously the moment you design a particular model. Okay, you are going to test it and you are going to further proceed with the development. That is what I call it as a test driven development. In some cases, what happens, complete development takes place at one stretch, then testing phase will begin. But in certain cases, the parallel processing of the software, that is parallel testing, is being done along with the development. That is what we call it as a test driven development, TDD. Statement coverage basically deals with the executable statement, that is testing the executable statements in the source code. Okay, after that, we have something, the formula for finding the statement coverage or arriving at the quantitative measure associated with the statement coverage. What is that? It is very easy. That is the number of executed statements you are going to look at, and you are going to have a total number of statements in the source code. I'm going to get certain fraction out there, number of executed statements divided by total number of statements. Since I was telling you about it should be expressed in terms of percentage, you are multiplying it by 100. And whatever coverage you are arriving at, it has to be expressed in terms of percentage only. Okay, so statement coverage, the formula is very simple. You are going to look at the number of executable statements once you carry out the testing, and you have total number of statements within the source code. You are going to have a division operation over there. You are arriving at a fraction, and you are going to multiply by 100 in order to get the percentage. Okay, let me take one simple example over here. I have one method called prints. Okay, print is a method which is accepting parameters of the printed out integer, int a and int b. These are the parameters which has been accepted by the method called prints. Within that, I have a local variable over here. You already know it. I will not explain. Okay. After that, I have a one conditional statement over here. That is, if at all result, whatever is being computed in the earlier statement, if it is greater than 0, that means it is a positive. Otherwise, it is negative. Very simple code snippet I have taken. Okay. Let us try to find out the statement coverage with respect to different scenarios. Okay, how can I apply? How can I find out statement coverage with respect to this code snippet? Okay, scenario one. See, whenever you will be asked to write about statement coverage, you write the definition, but don't write theoretical answers over there. You have to take up certain code snippets and try to explain statement coverage by arriving at a quantitative measure, that is, code coverage you have to find out. You can take up any example, it's not that you have to take up this example only. you can take any code snippet and try to explain the statement coverage. Okay, scenario 1, since how many terms are involved over here, the parameters that it is accepting are only two, that is A and B. Let me give certain value for A and B. Suppose A value that I have taken as 3, it is purely testing. Okay, how these values are coming out? It is testing. You can take any value and you can test your code. A equal to 3 and B equal to 9. What is the result? Result is going to be 12. So, it is, as you know already, once the control gets transferred to a particular method, it is going to be again a sequential flow of control. Okay, here first statement, the parameters that are passed will be stored over here, A and B, that is 3 and 9. The result is going to be 3 plus 9, 12. If at all result is greater than 0, it will check that condition. Whether 12 is greater than 0, definitely it is evaluated to true. Then it will print positive along with the value associated with the variable result. Then it will not execute this particular statement as you already know it. Okay, because this particular condition is satisfied, the control move towards the end of the method. Whatever I have highlighted with the yellow color, those statements get executed. Okay, so the statements that are marked in yellow color are those which are executed as per the scenario that I have taken over here. Okay, so how many statements are getting executed and how many number of statements are present in this particular code snippet? If you see, okay, this is one statement, 2, 3, 4, 5, 6, 7. Even this curly brace is also considered as one of the statements. So totally I have 7 statements in my code snippet, but how many statements are being executed as per the scenario that I have considered? 1, 2, 3, 4, and 5. And as per the formula, statement coverage should be number of executed statements divided by total number of statements into 100. So how many statements are being executed? 5. Okay, 5 statements are executed, and I have 7 statements within my code. That is 5 divided by 7, which is going to be 71%. Okay, and you have to indicate via diagram like this. This is the code coverage with respect to the scenario 1. Scenario 1. After that, I have taken up one more scenario where I have changed A and B values. See, testing is very tedious job. You have to look into all the possibilities. If I pass any value for particular input variables A and B, what is the outcome that I am going to get? That you are looking into. And the job of the software tester is very, very important in the software development life cycle. Okay, he is the one who will just tell you about the faults associated with your code. And you should be very thorough with the code, especially when you are dealing with structural testing. Okay, so whenever I have the value like A equal to -3 and B equal to -9, so what happens? I've taken the same code again. Result is going to be -3 -9, which is equal to -12. It comes over here. Whether result is greater than 0, whether -12 is greater than 0, no. So it will move on to the else part of the code snippet. It will print a negative along with the value associated with the result variable. Okay, the statements which are being marked in yellow color are the executed ones. Okay, as per the scenario, as per the values that I have taken. So how many statements are getting executed over here? 1, 2, 3. This has been skipped. 4, 5, and 6. So totally 6 statements are being executed out of 7 statements. So statement coverage is going to be 6 divided by 7 into 100. 6 divided by 7 into 100, that is going to be 85%, and you have to indicate via a diagram like this. 85%. This is how I'll be arriving at a quantitative measure associated with statement coverage. And you have to know this formula, number of executed statements for a particular code which is under study divided by total number of statements into 100. Okay, so what is the objective, or what all are the things that I can test using this statement coverage? Which all are the things that are being covered by this statement coverage? So, by looking at this particular quantitative measure, I can get to know about which all are the statements which are unused in my code. Okay. Sometimes what we will do as a developer is that we do include the statements within the code, source code, but they are left unused, never used. For example, one scenario can be you might have declared the variables, but you might have never used in the further processing of the variables. Okay, you might have never used those variables which you have declared earlier. Those are unused statements. You have written, but you have included. Okay, so such things will be known to you via statement coverage. And dead code, that is, which is of no use to you. It is simply lying. Okay, certain statements are just present just like that without any beneficial to the developer, dead code. Unused branches. Okay, you have written certain conditions, but they are not being used. And certain missing statements. Okay, you have written a conditional statement. For example, one scenario can be, but you have not written associated statement for that particular branch. That what I can call it as a missing statement. Okay. These things can be known to you via statement coverage. Why we have to go for statement coverage? Because these things are covered by statement coverage. Okay. After that, we have something called decision coverage, which is again most important point in structural testing. Whatever we are dealing with or whatever we are studying now, it is under the heading structural testing or white box testing or glass box testing. Okay, what do you mean by decision coverage? It is also one of the white box testing techniques which reports the true or false outcomes of each Boolean expression of the source code. Here the focus is on the evaluated value associated with the conditional expression or the Boolean expression. So important key terms that you have to remember over here. It is again a white box testing technique, okay, which deals with, which is going to report you about the true or false outcomes of particular Boolean expression of the source code. And what is the objective with respect to decision coverage? Okay, the objective here is to cover as much as possible the source code and validate the source code by checking each branch of every possible decision point. Okay, we are going to cover as much as possible the conditional of the Boolean expressions that we have written via decision coverage, and you are going to validate the outcomes associated with particular Boolean expression. At least once. This is most important point that you have to remember. At least once you are going to traverse to the source code and you are going to access the Boolean expression and you are going to deal with the outcomes associated with the Boolean expression at least once. And as you already know, the Boolean expression will have either one of the values, either true or false. So you are going to validate it, whether it is happening properly or not, by going for decision coverage. Okay. After that, okay, in this coverage, okay, expressions can be sometimes very complex. Okay, so it is very hard for a tester to achieve 100% decision coverage. Okay, because the expressions that you have included in the source code can be very complex and it is very difficult for a tester to achieve 100% coverage via testing. Okay, so we have got various methods for reporting or for measuring this particular quantitative measure. Okay, so these methods will focus on various combinations. Okay, they go for computational combination by considering various scenarios in order to test the Boolean expressions which are complex in nature. Okay, after that, okay, let us just go through the formula that we can use in order to have the decision coverage. How we measure decision coverage. So decision coverage is computed using the formula the number of decision outcomes exercised divided by total number of decision outcomes. We look at the example how this particular formula is made use of. Okay, but you have to know this formula. What is the formula for decision coverage? Is that it basically deals with the outcomes of a particular decision. So number of decision outcomes exercised. What is the outcome that you are getting by considering a particular scenario divided by total number of decision outcomes? It is going to be 2. Okay, decision outcomes can be either true or false. How many are there? 2 are there. So total number of decision outcomes it is going to be 2. So let me consider a simple code snippet over here. I have written a method called demo which takes a single parameter called a which is of a type integer. Suppose if a is greater than 5, I am doing the mathematical calculation, that is a starting, that is I am multiplying the value of a by 3 and I am printing it. There is no else statement over here. I have only one conditional statement if. Okay, let me take up the scenario over here. Scenario number 1. If the value of a is 2. See, just place the code over here. Okay? And you should have much patience whenever you perform the job of a tester. Okay, you should thoroughly go through the code and you have to trace the code against various values for a particular variable. Suppose here the scenario I consider a value as 2. What happens here? If 2 is greater than 5, is 2 is greater than 5? No, not at all. So where it has to go? It has to go to print a statement. Okay, print a, it is not included within if. If it was included, then I would have put a curly brace after if. Only one statement is there within if statement, that's why I have not used curly brace. The one statement which is associated with the if is a is equal to a star 3. Multiply a value of a by 3. Print a is outside if statement, if the block. Okay, so what happens if 2 is not greater than 5? So you are just printing the value of a which is equal to 2. Let me show you this. Okay, the yellow color highlighted lines are the ones which are executed against the value of a, that is 2. So what is the decision coverage over here? Here the outcome is no because it is evaluated to false. Am I right? 2 is greater than 5. Here you are not dealing with the number of statements executed. You just forget about statement coverage right now. You are dealing with the decision right now. The decision made out over here is that either it has to be true or false. Either I have to enter into a statement or I have to come out of a statement. Okay? 2 is not greater than 5. So I have to come out of the if block and I have to print this. That's why the evaluated value is false, which is equal to 1. As per the formula, number of decision outcomes exercised is only 1 here. That is false value divided by total number of decision outcomes. As I have already told you, it can be either true or false. So total number is 2. 1 divided by 2 is 50%. So decision coverage is going to be 50%. Okay, I hope everybody is understanding this. Okay, there is a difference between statement coverage and decision coverage. After that, we have taken up one more value, which is the value of a is 6 over here. So, coming over here, is 6 greater than 5? Yes, definitely it is greater than 5. And you are entering into if a block, that is 6 into 3. I am assigning the value of a as 18. And after that, it is a sequential execution. I am printing the value of a which is equal to 18. So here we are not bothered about how many statements are getting executed. We are bothered about the decision made. So just focus over here. 6 greater than 5, it is true. So what is the outcome? How many outcomes have been exercised? Only one outcome at each instance of time. That is true. So 1 divided by total number of possible outcomes for a particular decision. It can be either true or false. Total number is evaluated to true. 1 divided by 2, which is again equal to 50%. Okay. This is how we will be computing the decision coverage. Okay. Each and every terminology you have to be very specific. You cannot mess up with these things. Okay. You cannot mess up the decision with branch coverage. Both are different. Okay. Decision is different, branch coverage is different. Okay, the things that are being dealt via these coverages are different. The perspectives or the context in which they are used are different. Even though you are dealing with the same conditional statements, the context in which they are being used in the testing, they are different. Okay? So decision coverage is going to be 50% in both the cases. After that, I have something called branch coverage. Okay, what do you mean by branch coverage? So branch coverage is also one of the white box testing technique. Okay, wherein the focus is on the every outcome from a code module. Basically, it can be either statement or a loop which is being tested. We are going to focus upon all the outcomes from the code module. Basically, again, I am dealing with the conditional statements, in other words. Okay, what it basically do? It basically ensures that each condition statements that are written or included in the source code, from every branch it is executed at least once. You are dealing, see, focus on the word branch here. In the previous thing, the main actor was decision. Here it is branch. See, for a particular condition, it will have two branches. Am I right? True branch, false branch. Okay. If it is evaluated to true, the true branch of a particular conditional statement gets executed. Otherwise, the false branch gets executed. So you are taking care that you are going to test each branch of a particular conditional statement at least once via branch coverage. Okay, it is basically helping us in measuring the fractions of the code segment and to find out the sections having no branches. So you can differentiate clearly between the conditional and non-conditional statements in the source code. Let us study the formula associated with the branch coverage. Okay. For example, the outcomes are going to be binary. You already know either it is true or false. With branch coverage, you are supposed to test both true and false outcomes. Okay. This was not the scenario in the previous coverage. That is, decision coverage did not emphasis on testing both the outcomes. Whatever outcome was there, with that we were expressing the coverage. But here, it's your responsibility to write the test cases in order to test both true and false outcomes with respect to branch coverage, because you are dealing with the branch of a conditional statement. Okay, so branch coverage, the formula should be number of executed branches divided by total number of branches. This is the formula which is associated with branch coverage. Okay, you have to remember this formula. Number of executed branches divided by total number of branches. Okay, let us just go through one example for branch coverage. Okay, same example we have taken, wherein I am testing the value for A. If it is greater than 5, I am increasing the value by 3 times, and you don't have any else part for this. You have just one statement outside this block, that is printing the value of A. Let me just measure the branch coverage for this. Okay? And with this, we can actually differentiate between conditional branch and unconditional branch with the help of branch coverage. Okay, so if you look out over here, this is the flow with respect to the particular code snippet which is under study. Okay, here if you see, if the value of A is greater than 5, okay, then it has to be either true or false, as I've already told. There are two outcomes for each conditional statement. It can be either true or false. If it is true, I am multiplying the value of A by 3 times. Then if it is false, I am not doing anything. I am coming out of the if block and one statement is common for both of them. That is printing the value of A. This is what I call it as an unconditional branch, because you don't have any conditions to traverse or to go to this particular block. Whereas in order to go to this specific block, it has to be true. The condition should evaluate it to true, then only you can go to this particular block. For going to this block, you need not have any condition. You need not check for a particular condition in order to traverse, in order to go to this particular block. That's why they are telling this as unconditional branch, and this is a conditional branch. Okay, by branch coverage, you are differentiating between the conditional and unconditional statements in the source code. Okay, so in branch coverage, we are going to consider even unconditional as well. Suppose value of A is 2. Suppose the value of A is 2, then what is the output you are going to get? Okay. Suppose the value of A is 2. 2, is it greater than 5? No, not at all. So I'm just printing the value of A. That is, the output is 2 over here. That's what they have written. And what is the decision coverage? Based on this formula, number of executed branches. How many branches are executed? If I go for this, okay, it is directly coming over here. So it is 1 divided by 2 branches. Out of 2 branches, it is 1 divided by 2, which is equal to 50% as per decision coverage that I have taken. What about branch coverage? They have arrived at 33%. It is 33%. How is it so? Okay. See, how many branches are there for this particular?
7, 7, just a minute.